This brings us to our first exercise, where we will do a very simple Monte Carlo analysis using only Microsoft Excel. You're asked to generate the cumulative distribution function for a minus b and to calculate the mean of the distribution. We are told that a and b are both uniform distributions and to perform 1,000 iterations, which the spreadsheet is conveniently set up to accommodate. From earlier in the presentation, we know that the function that defines the CDF for a uniform distribution is equal to x minus a divided by c minus a. For a given iteration, f of x is going to be equal to a random number between 0 and 1. We know that a in the equation is the minimum value and that c is the maximum value. So we can then solve for x, which will be the result of the distribution for the iteration. So to start, we punch in the rand function in cells C17 and E17. That's RAND, followed by open and close parentheses, then hit enter. We can then drag the formula down in both columns to complete all the cells in the column. The rand function will update every time a cell in the spreadsheet changes. This can be really annoying, so I copied each column and then pasted as values back into the same place so that they would not keep changing. Next, we will solve for x for distribution A. X is equal to f of x times c minus a plus a. F of x is the random number between 0 and 1, and we're multiplying that number by the maximum minus the minimum for distribution A, then adding the minimum value from distribution A. I'll repeat that process for distribution B, solving for x from the same equation as before, but using different inputs. We'll use a different random number, and we'll use the minimum and maximum values for distribution B. X for a minus b will be equal to, you guessed it, a minus b for that iteration. Once those formulas are set, I can then drag them down to columns D, F, and G to complete the table for the remaining iterations. Next, we need to build the CDF for A minus B. To do this, copy the values in column G and paste as values into column J. Sort the values from smallest to largest. Each of these values will have a probability of 1 over 1,000 because there are 1,000 iterations and each iteration has the same probability of occurrence. So the cumulative probability will be the iteration number divided by 1,000, which is the number of iterations, B14 divided by 1,000. Then we will drag that formula down to the bottom to complete the table. All complete, the CDF should look something like the curve on the right. For this analysis, the mean was equal to 69.2, but will be different for your analysis because a different set of random numbers will be generated. Had we done more iterations, the mean of everyone's analysis would have been much closer to the theoretical mean of 68.5. But 1,000 iterations does pretty good and shouldn't be off by too much.